Hey everybody, welcome to the definite integral. We're going to be talking about right Riemann sums. So this is our second video. So hopefully you've already watched the left Riemann sums. Okay, so let's go ahead and get some definitions out of the way. When we take the area under the curve with right rectangles, we use the following equation. Okay, so the big difference here is you're not using f sub 0. You're not using the first endpoint, the one on the left. You're actually going to be using the last endpoint, okay, the b value. So this is like f of b right here. There is no f of a, okay? And that's different from the left Riemann sum. The left Riemann sum, you'd use f of a, the a point. You would not use the b value. So here's our equation. You remember b minus a over n is the width of each rectangle. N is the number of rectangles you have to create. So we're going to use the same drawing as we did in the first video with left Riemann sums. So we have the area of x squared we're looking for. Now, this is an increasing function. Notice how there's so much rectangle above the function. So when our function's increasing, you can probably expect you're going to have an overestimation of this area. Okay, so let's go ahead. We're going from 0 to 4. We're using 4 endpoints, or right endpoint rectangles. And the big difference here, notice how we go 4, 3, 2, and 1. That's what's being plugged in. We're not going to be using that left endpoint 0. So we're going to be getting in here. You're going to see f of 4, f of 3, f of 2, and f of 1 when we do this. Okay, so watch. So we're going to have delta x. That's that width of each rectangle is b minus a over n. N is 4. Okay, so we're going to have, okay, we're going to go ahead and have 1 is our width. Okay, so that means when I set up my interval, I started from 0. I'm going to 1, 1 to 2, 2 to 3, and 3 to 4. Before I used these for my left, now I'm going to be using these for my right, these 4 values. Okay, so the area here is going to be equal to 1. That's the width of each rectangle. That's why it's out front. We factored it out. And you're going to be looking at f of 1 plus f of 2 plus f of 3 plus f of 4. And there's the b value right there. Okay, so we use these endpoints. Those all have to be plugged in. 1, 2, 3, and 4 have to be plugged in to x squared. Okay, so I go ahead and do that. And I'm left with f of 1 is 1. Plus 2 squared is 4, 3 squared is 9, and 4 squared is 16. Okay, and so my area under that curve is 30. This is going to be an overestimate. Okay, let's go ahead and look at it when we change the number of rectangles. We're going to add some more rectangles here. Okay, same curve. Okay, now there's 8 rectangles, so each function, or each rectangle endpoint, there's going to be more of them, okay? Notice how there's still an overestimation, okay? There's still a rectangle above the function, but look, f of 4, 3.5, 3, 2.5, 2, 1.5, 1. Those values hitting the curve are what we're going to plug in. Those are going to get us the heights, okay? So delta x, we're going from x squared from 0 to 4 again, 8 rectangles, so our delta x is going to be b minus a over 8. N is 8 this time, so each width is 1/2. So when we do this, when we go ahead and put this together, we're going to have the area equals 1/2 times, okay? Now, here's the thing. We start at 0 and we go to 1/2. And I'm going to go half to 1, 1 to 1.5, and we keep going. Okay, 1.5 to 2, 2 to 2.5, 2.5 to 3, 3 to 3.5, and 3.5 to 4. Okay, here's our right side. Okay, there's the right side. That's what's going into the function. I hope I have enough space. So let's go ahead and write this. Area equals 1/2, okay, times f of 0.5 plus, so each one of these values now is getting plugged into the function. These are all the heights. So f of 1 plus f of 1.5 plus f of 2 plus f of 2.5 plus f of 3 plus f of 3.5 and f of 4. I can squeeze that in there, okay? Now, we have to evaluate all those numbers. They have to be plugged into our function. Okay, so good at it. I went ahead and did that ahead of time. So we get 0.25 plus 1 plus 2.25, right? 1.5 squared plus 2 squared, there's 4, plus 2.5 squared is 6.25. Okay, plus 9, 3, there's your 3. Then we got to do 3.5 squared. 3.5 squared is 12.25. And 4 squared is 16. So now I've got all my numbers in there, okay? So now I get 1/2 times that sum, which is the sum I got to be 51, okay? And that's going to equal 25.5. Notice how with the more rectangles I had, the area dropped because it's going to be a better estimation the more rectangles I have. So that is right Riemann sums using right endpoints. If you have any questions or comments, you can go ahead and type them below, everybody, and we'll see you next time.